Okay, what is the value of f prime of 0? That means take the derivative and plug in a 0. I'm going to first write my functions. I have a tangent of x somewheres. I got a sine of somewhere, huh? And I got a 2x. Well, I can see already that the 2x is on the very, very most inside. The very, very most outside is tangent. Yeah, tangent. I burped. Excuse me. Well, I don't know why I just wrote tangent. It's outside. And it must mean the sine is in the middle. And I'm not writing what is... So, let's take the derivative. F prime of x, that's just, well, the derivative of the outside, derivative of tangent, is secant squared. With the inside the same. Well, the inside is the middle part. So there we have the middle part. With the inside the same. But now we go to times the derivative of the inside. Well, the inside is the middle part. We just said it. So now I do the derivative of sine because I'm doing the chain rule again. The derivative of the outside, which is cosine, with the inside the same. 2x. Times the derivative of the inside. Okay, now this time it's 2x on the inside, so the derivative is 2. Well, isn't that very that's dandy. And so every we still gotta plug in 0. Yes, we do. We do. So if I plug in 0, sine of 2 times 0 is 0. Sine of 0 is on the unit circle. 0. The sine of that is the y-coordinate of that point, so that would be 0. So I have secant squared of 0, which is the same thing as 1 over cosine of 0 quantity squared. I can square it because the 1 on the top, just 1 squared is 1. But maybe I'll write it differently so that it's there. Both of those mean the same thing, just because 1 squared is 1. Oh, cosine of 0. Cosine of 0 is 1. So 1 squared is 1. This is 1. So this whole thing is 1. We got to do times cosine of 0, that's, we just said, 1, times 2. And so we get 2. And that's how life goes. This is a 2. That's all she wrote. Emma the D, you're not a she. Are you a she? I'm not a she. Sorry. That's all I wrote. Okay. Example 17. We have what we have. What we have? Oh, we have weird looking one. We have square root in there. We have a lateral log. And we have 3 legs. So, I write down my functions, huh? I have a square root in there. I have a natural log in there. And I got a 3x in there. Those are my 3 functions. The square root is the outside-most one. Right? The natural log is the middle. And the inside is a 3x. That's the inside. I'm just, for kicks, I'm going to write down the derivatives. Actually, it would maybe help you if you did this. 1 over x, that's the derivative. And the derivative would be 3. Okay. Let's do this. What is the rule for f prime of x? That just means find f prime of x. Find the formula for the derivative. Find the equation for the derivative. Alright? Find it. Look for it with a flashlight. Search party, maybe. Don't search the party. All you find is, well, the water. Hopefully you flush the... Never mind. Okay. The outside function is the square root of x. And the derivative of square root of x, I just said, is 1 over 2 root x. But we're doing the chain rule. So it's the derivative of the outside with the inside the same. So I actually have 1 over 2 times the square root of the inside, which is the same. So I leave that. Oh, that's nice. And then I got to do times the derivative of the inside. Well, that's chain rule again. Okay, the derivative of the outside here would be the derivative of natural log. That would be 1 over, normally it would be 1 over x. We don't have x on the inside. What do we have on the inside of the natural log? We got 3x. So it's 1 over 3x. Hopefully that makes sense. Derivative of the outside with the inside the same. Times the derivative of the inside, we know that that is 3. And so we have, ooh, that cancels. We have 1 over 2x square root of the natural log of 3x. Right? Is that one of the answers? There we go. Yeah? Yeah. Yeah. Alright. Example 4. Ooh, we can make example 4 before the end of this video. Any questions? It's a video. You can't ask questions. We know this already. Do we not know this? Yeah, but did we know this? Alright. On this one, f of x equals e to the sine of 2x. I'm going to write down my 3 functions. I know I have an e to the x, I have a sine, and I have a 2x. This has got to be the inside, because this is all the way on the inside. E to the x is on the outside. Okay. I don't know how you can tell. It's just by, like, I don't know, maybe there should be parentheses around there. I don't know. Hopefully you get used to it. And this will be the middle. Okay. Derivative e to the x is just e to the x. Derivative of sine is cosine of x. Derivative of 2x is 2. Well, that's very nice. That's very nice. That means f prime of x, well, derivative of the outside, that's e to the x, with the inside the same. So that's e, normally to the x, but we don't got an x. What do we got? We got sine of 2x. Who are you talking to? And then times, so the derivative of the outside with the inside the same, times the derivative of the inside. Well, what's the derivative? Oh, chain rule again. So I got to do derivative of sine. That's cosine. Normally cosine of x, but we got to keep the inside the same because we're using a chain rule again. Derivative of the outside with the inside the same times the derivative of the inside. So I got the 2 there. So I got 2 cosine of 2x times e to the sine of 2x. And I'm going to plug in pi over 2. If I plug in pi over 2 here, the 2's cancel, so I get cosine of pi, right? Well, maybe I'll write it. Some people will be like, what are you doing? I'm just doing the math. So it's just really cosine of pi. Same thing happens here. Pi over 2 cancels. Okay, so what do you get? You get cosine of pi is -1. So 2 times -1 times e to the sine of pi is 0. So e to the 0, that's just 1. So I get -2 times 1 is -2. And everybody's happy. Everybody goes home, eats a sandwich, maybe takes a nap, and then we leave. We're done.